Okay, let's go ahead and get started. So what I just passed out to you is a set of z-tables like we were using last time. So the first one is our positive z-table, and remember that a positive z-table is going to be useful, of course, when we have a positive z-score, but those positive z-scores come from having an x value that is greater than the mean. So it's going to be something that looks like this. And then the opposite is true for our negative z-tables. So of course negative z values, but useful for where our x is less than the mean. So it's going to look something like this. Okay, so last time we were talking about how we can look at our data, and if it is normally distributed, we can make some calculations to find the locations of very specific data. So we'll just review that real quick. So if I have normally distributed data, something like this, where if this is frequency, then the parts of the curve that are very, very short represent data points that have almost no frequency, so maybe they only happen once or twice. Whereas the peaks, or in this case the single peak, represents the data that is occurring the most. And so of course the data point that we say occurs the most is the mode. However, we also said that if it's normally distributed, then this middle point will separate these two halves into exactly equal halves, meaning that this is also the median, the middle point. And it should also be our mean, our average. Now, what we can do is we can find a particular x value and calculate the percentage of data that is behind it using our z-table. So we can take this x value right here, whatever it may be, do just a little bit of math with it and figure out how much data is behind it. This is very useful for probability because, for instance, like with our light bulb example from last time, we could use this to select the light bulb off the assembly line at random and figure out what the chances that it will have a particular lifespan. Okay? So let's just try this out real quick. Of course, to perform our calculation, we need a z-score, and that z-score is z equals x minus mu, the mean, over sigma, our standard deviation. So let's get some data points in here. Of course, we need three of them. We need an x value, whatever this point is right here, a mean, and a standard deviation. So let's say that our mean is 70. Our standard deviation is maybe something like 10. and then our x, we want to calculate less than or equal to 50. Okay? So again, we're calculating if this is x, which is 50, then this part here, all of this back here, is x is less than or equal to 50. Does that make sense? Yes? No? Okay. So, we want to know how much of our data is back here. What is the percent? Because that percent will let us also get a probability. So let's just go ahead and plug these numbers in and see what it gives us. So z equals x is 50. Then mu, mean, is 70. And sigma, standard deviation, is 10. So now we just need to follow through with our order of operations and see what we get. Of course, the first thing we need to do is figure out that top part. So 50 minus 70 is going to give us what? What? Negative 20, good. So now z equals negative 20 over 10. Okay, and so divide that. Negative 20 divided by 10 gives us a z of what? Negative 2, yeah. Okay, so we have a z-score now, but the z-score is not our probability. The z-score is not what we're ultimately looking for. What we want is a probability, so we have to take this z-score and look up the probability on our z-table. So remember that this is a negative z-score, so we need our negative z-table. That's the second page. Let me make sure you get one. So again, look at our negative z-table, and we're looking for 2 exactly, not 2.01 or 0.2 or anything, but 2.0. Okay, so z-table, negative values. We look for that 2 first on this side, and there it is. And then we, again, are looking for 2.0, not 0.1, not 0.2, not 0.3, but 0. So there's our 2.0. And so if we follow that down, we get our probability. Now in this case, it is 0.02275. So our probability is 0.02275. So the probability that we would select any data point at random from this set of data and it falls in this area is this. Of course, we can also convert this into a percent by moving this decimal twice to the right, and that would mean that we get a percent of 2.275%. So then we can also say, okay, well that means that, about 2%, just over 2% of our data lies in this area right here. Any questions? None? Okay. So, again, what we can do with this formula right here is we can find the amount of data that lies behind a certain point. And again, behind a certain point, that's what our tables tell us. It's only behind. But if we want to know ahead, so not this part, but the part on the other side, so all the stuff that is above 50, we don't need the table to tell us exactly what that is. This is enough right here. So let's say that we want to know also this part, which is x is greater than or equal to 50. So again, this part is x is less than or equal to 50. This part is greater than or equal to 50. Well, again, all we really need is this probability that we've already gotten, because this tells us the amount of data that is back here. Now, keeping in mind that this entire set of data represents a probability of 1, all we really need to do to find this side is to take this part off, just kind of snip it off and see what's left over. Literally, we're going to subtract this side from the entire thing. So once again, if the entire thing represents a probability of 1, then we need to do 1 minus this side, which is 0.02275. Does that make sense? Any questions? Okay, so let's see what that is. So 1 minus 0.02275, we get a probability of 0.97725. Or if we wanted to make that into a percent, of course, just like before, we take this decimal and move it twice to the right, and we get a percent of 97.725%. So 97, almost 98% of our data occurs on the other side of 50. So this whole area right here. Make sense? Any questions? None? Okay. So that's what we covered last time. So we can calculate behind a particular point. So if this is our point, we can calculate everything that's back here. We can also calculate the amount of data that is in front of it by doing the same thing, but then just subtracting it from 1 to give us that. So on Friday, I left us with this. We know how to calculate above and below. Well, how would we do something like this? In between. Okay, so let's think about it. Like we said before, we know how to calculate above and below. If we want to calculate below, it's pretty easy. We just plug in our numbers, get our z-score, and look it up. And that'll give us what's below. If we want to get what's above, again, we do the same thing, get that probability, but then subtract it from 1 to get the other side. So if we want what is in between, what we need to do is basically get rid of that part, the stuff that's below, and this part, the stuff that's above. So let's see how to do that. Let's say that I've got some values here. My mean is, what did I use? 72. So mean, mu, equals 72. Then maybe we have a standard deviation of 2. And then we have two x values, one right here and one right here. The lower one is 65, and the higher one is 69. So what we have here for our x is 65 is greater than or equal to, I'm sorry, is less than or equal to x, and x is less than or equal to 69. In other words, x is somewhere between 65 and 69. So essentially what we need to do here is we need to calculate two z-scores. One for this 65 and one for 69. So let's set that up. So our first one, z equals 65 minus our mean, 72, over the standard deviation, 2. And then the second one, same thing, z equals 69 minus the mean, 72, over the standard deviation, 2. So again, we got to calculate two z-scores, one for each of these x values. Let's go ahead and see what this comes out to be. First of all, 65 minus 72, and then divide by 2 gives us negative 3.5. Okay, and then the other one, 69 minus 72 divided by 2 is negative 1.5. So there's our two z-scores. Okay. So now we need to think about what we actually have here. Again, these z-scores calculate things below, right? So this one, if we think about it, is calculating all of this area back here. And this one is calculating something similar. Whoops. It's calculating all of this area back behind it. But we don't want this area back behind it. We just want this. So this one, it's got this part right here. This is our first z-score. In fact, I'm going to call this z1 and this z2. z1 is all of this back here, right? So we can subtract that one, that's fine. But z2 is all of this part and this part. It's calculating all of that. We don't want to calculate that. We don't want to get rid of this. This is fine. We can chop that off. But this z2 needs to get rid of this part, the stuff above it, not below it. Okay? So let's go ahead and find our probabilities, and then I'll let you think about what this means. So, looking at our negative z table, negative 3.5 is a probability of 0.00023, and then this one, negative 1.5, is 0.06681. And again, it's calculating back behind it. We don't want it to calculate behind it. We want to calculate above so we can get rid of this part. So what are we going to need to do with this so that it calculates above instead of below? We just did it up here. Do what? I can't quite hear you. Not add them. If we add them, it's just going to give us this whole thing, just this part. Yes. So right now, since it's calculating back behind it, again, what we do if we want to calculate above it from 1. So once we subtract this from 1, it will give us this part. So this part is right here, and then once we subtract this from 1, it'll give us this part over here. Everything that is not what we're looking for. So 1 minus 0.06681. See what that is. 1 minus 0.06681 is a new probability of 0.93319. So this right here is 0.00023. This right here is 0.93319. Oh, whoops, that should be all the way here. So we know both of these parts, we don't want them. We want to get rid of them. We just want this part left over. So what are we going to do with both of these? Subtract them from? Yeah, subtract them from what? 1. Since the whole thing is 1, we subtract them from 1, and we'll get whatever's left over. So 1 minus this, so get rid of this part here, 0.00023, and then minus this whole part right here so we can get rid of that, 0.93319. So that gets rid of both of these, leaving us with just the thing that we're looking for. So 1 minus 0.00023, and then minus another 0.93319 gives us that this part here in the middle is 0.06658. So, in between these 2 points, about 6% of our data is right there. Any questions? Okay, so for these, if you want to calculate between, you got to think about what you're actually doing. Yeah, we can do both of these z-scores for both of these x values. But since they both calculate below, well, which one of these do we need to flip to be above? Well, this one, we want to get rid of that. It's calculating just from here to here. That's fine. We want to get rid of that. We can subtract it. This one, on the other hand, is also calculating back here. It's basically telling us what we already know, so this is the one that we want to flip to this side so we can subtract it. And once we subtract both of those, we only have what's in between. Again, any questions? So add them both and then subtract by one? No, that'd be perfectly fine. Now, you have to take this one and subtract it from 1 first to get this, so it's flipped. But if you add this, and then subtract that from 1, it will give you the correct answer, yes. Any other questions? None? Okay, I've got one more thing I want to show y'all before we leave today. Okay, this is pretty short, but I know y'all are going to encounter it on HOX, so I want to make sure that you see it here first. So again, let's say we have normally distributed data. Okay. Now let's say we know the amount of data behind this point. So this shaded region right here that I've just shown us is what we know. And let's say that it has a probability of 0.99224. Okay? Or in other words, 99% of our data is in this area. Well, if we know this, what do we do to find this number, the x? How do we see where this stops? Okay, that'd be useful because, I mean, yeah, okay, 99% of our data lies there, but what is it below? What is the range of this area? Obviously it goes from whatever our lowest is, but where does it stop? So how do we find this x? Well, before we go any further, I'm going to tell you this right now. With only this information, you cannot find a number for x. What you can do is find an equation for it. And HOX is going to want you to do that, so let me show you how to do it. So what we've been doing so far is we've been taking an x and getting to a probability. So we take the x, put it into our z-score formula, get that z-score, and then look up a probability, right? So if we want to do the opposite, go from a probability to x, basically we just have to do what we've been doing, but backwards. So we have our probability. And it's quite large, so we know that it's going to be positive. This x value, whatever it is, it's above the mean, so it's going to be a positive z-score. So what we need to do is we need to look at our positive z-table and find this probability somewhere in these numbers. So let's see, we first need to find 0.99 numbers, so here's 0.992. That's pretty close. And in fact, 0.99224 is right next to it. Okay, so now we need to look up what this represents as a z-score. So the first two digits are 2.4, and then the next digit is 2. So altogether we have a z-score of 2.42. Make sense so far? Okay. Now, in order for us to really figure this out, we need the mean and the standard deviation. It's not giving us that, though. But what we do know is that z equals x minus the mean over standard deviation. This is our formula for z-score. It's what we've been using all day today. Okay, so what we can do is we can say, well, if I know the z, then I can put that in for z. So 2.42 equals x minus the mean over the standard deviation. And again, now what I want to do is I want to find x. So I need to get x by itself. I need to take anything that is not an x and cancel it, and it'll be on this side. So, what looks like it'd be easier to cancel, the mean or the standard deviation? Well, give us a hint. The mean right now is tied up in this fraction, and that fraction's kind of being annoying right now. So we want to get rid of that fraction. Do what? Yeah. So the whole thing is being divided by standard deviation. So the opposite of dividing by that standard deviation would be to what? Yeah, multiply. So multiply by the standard deviation, and that will cancel both of these. But of course, whatever we do to one side of our equation, we need to do it to the other side. So multiply by standard deviation on this side as well. And so on this side, we are left with x minus mu. And then this side, let's see, 2.42 times sigma. Well, the best we can get out of that is 2.42 sigma. Okay? Okay, the last thing we need to get rid of is the mean. So how do we cancel the mean on this side? Add it. Of course, we need to do that to both sides. So negative mean, positive mean, cancels their opposites, leaving us with just x, and that's what we want. We want x by itself. But on this side, we will have 2.42 sigma, oh, whoops, that's really low, plus mu. I'll rewrite that, that looks really messy. 2.42 sigma plus mu equals x. So again, without the sigma, the standard deviation, and the mu, mean, we can't actually figure out what x is. We would need both of those values. But we can still come up with an equation that represents it. Any questions? None?
The algebra answer that we put on class, right? That's all that answer?
Yes. Any other questions? None? All right. So I think that will do it for today. Remember that next week, Wednesday is a holiday. There's no class on Wednesday. Also, next week, I want y'all to be expecting a quiz. I haven't decided if I'm going to give it on Friday or Monday. It'd be kind of mean to give it on Monday, wouldn't it? So it's probably going to be on Friday. Just be prepared for a quiz sometime next week. But it's going to be over all this stuff. Okay, so know how to calculate a z-score, and know if you need to change it from calculating behind to above. Okay? But that'll do it for today, so I will see y'all on Monday. Have a good weekend.